Phase space diagrams are useful tools for analyzing all kinds of dynamical problems. They are especially useful in studying the changes in motion as initial position and momentum are changed. Okay. Here we consider some simple dynamical systems in one motion. For such systems, phase space is a plane in which position is plotted along a horizontal axis and momentum is plotted along the vertical axis. Okay, so position versus momentum. Fine. The phase space is xt versus pt curve. The arrow of the curve indicates the time flow. For example, the phase space diagram for a particle moving with constant velocity is a straight line as shown in the figure. So this is the point. So we use the sign convention in which position and momentum upwards, and this right is positive. Okay. Downwards. The phase space diagram for a ball throwing vertically up from the ground is. So when the ball goes up, okay. So now what happens is that initially, if we see, initially at 0, momentum is like quite big. And as it goes up, okay, as it goes up, the position, the momentum it keeps on decreasing and it goes to 0. Okay. Now the momentum changes its direction, it becomes negative, so therefore it's negative here, and then the momentum keeps on increasing and it comes to be like when it is touching the ground, then the momentum becomes like more, and it's almost same. So therefore the only option which we are seeing is D. Why we reject the other options? So you see here, position, position was never negative. So when a ball goes up, so this is y is equal to 0, there is no way that the y becomes negative. Y is always positive, so the position is always positive. Position can never be negative, so therefore A is rejected. B again rejected for the same reason, because position can never be negative. C also, position can never be negative. Okay, so therefore there's only one option, which is D, where the position is positive for both the ball going up and for the ball going down. Thank you. The position vector is given by this equation. लिख लेते हैं हम लोग अल्फा टी क्यूब प्लस बीटा टी स्क्वायर. This is I cap and this is J cap. So at t equals to 1 second, which of the following is true? So इसको differentiate करते हैं, dr by dt, which is velocity. This becomes 3 alpha t square I cap plus 2 beta t into J cap, which is 3 into 10 by 3 I cap plus 2 into 5 J cap, which is 10 I cap plus 10 J cap. This is the velocity. Okay, this is for 1 second. R at 1 second is 10 by 3 I cap plus 5 J cap. This is R at 1 second. So now the velocity is given by, yes, that is true. Angular momentum with respect to the origin is given by this. So angular momentum is R cross mv. This is angular momentum. So R is 10 by 3 I cap plus 5 J cap cross m. M is 0.1 kg, and this R was in meter, into V is 10 I cap plus 10 J cap meter per second. So this becomes, so 0.1, so this we have I and J only. So I cap cross I cap is 0, I cap cross J cap is K cap, so 10 by 3 K cap. J cap cross I cap is minus, so minus 5 K cap, and J cap cross K cap J cap is 0. So therefore this becomes Now this is kg meter square per second, which we can also write as kg ms minus 2 into m into s. Okay, so this is Newton meter second, which is given here, so the units are also right. So now we have 10 by 3 minus 5 by 3, so therefore this becomes minus 5 by 3 k cap Newton meter second. So B is correct. C, the force is given by, so force is going to be ma. So now if we want to calculate acceleration, we can calculate here. So acceleration will be given by 6 alpha t I cap plus 2 beta j cap. So this becomes 6 into alpha is 10 by 3 I cap plus 2 into 5 j cap. So this is 20 I cap plus 10 j cap. Now this has to be multiplied by mass to get the force. So force is equal to m into a. So this becomes 2 I cap plus j cap. Now so C is wrong because it's actually the opposite. 2 should be here. The D part, torque. Torque is given by R cross F. So now we have R. R is 10 by 3 I cap plus 5 j cap, and cross F 2 I cap plus j cap. So this becomes I cap cross I cap is 0, so therefore I cap cross j cap, so 10 by 3 k cap, j cross I is minus, so minus 10 k cap, and j cross k is 0. So this becomes minus 20 by 3 k cap. Okay, and of course R is in meter, force is in Newton, so therefore Newton meter. So therefore D is also correct. So let us go step by step and then we will be able to solve everything. Thank you. T equal to 0 from the origin with speed 1 meter per second. A particle follows a two-dimensional trajectory. So there is a coordinate by given by y equals x square by 2. Okay, so let us write y is equal to x square by 2. So therefore let us differentiate. So dy by dt is equal to 2 into x into dx by dt. Therefore velocity in y direction is equal to 2 into x into velocity in x direction. That is first equation. Again we differentiate, we are getting ay is equal to 2 into, okay, it's x square by 2, so 2 is gone, so x vx actually. So ay is equal to dx by dt into vx plus x into dvx by dt, which becomes vx whole square plus x into acceleration of x. So therefore ay is vx square plus x into ax. This is the second equation. Now let us solve. So ax equals 1 meter per second square implies that when the particle is the origin, ay is equal to 1 meter per second square. Yes, so ax is equal to 1, so therefore ay equals vx square plus x into ay. At the origin x is equal to 0, so therefore ay is equal to simply vx square. Now at the origin, we see that vy, okay, at origin we can clearly see that vy is equal to x into vx, so therefore vy is 0 into vx, so therefore vy is 0. Now speed at the origin is 1 meter per second, so therefore whatever the speed is, that is due to Vx. So therefore Vx is equal to 1 meter per second, so therefore Ay becomes Vx square, that is 1, is correct. B, Ax equal to 0 implies Ay equals 1 meter per second square at all time. So here Ay is equal to, so Ax is 0, so Ax keep it 0, so Ay will become to Vx whole square. Okay, now Vx whole square, so therefore Ay actually becomes 1, but here it's given Ay equals Vx square at all times. Now since Ay is equal to, Ay is 0, Ay is 1. Now you see initial velocity is 1 meter per second, and in the question it is clearly mentioned that Ax is equal to 0. So since Ax is equal to 0, so therefore whatever is the initial velocity, that is going to remain. So velocity in x direction is equal to 1 meter per second at all times if Ax is equal to 0. So therefore Ay should be equal to 0. Okay, so Ay should be equal to 1. Okay, at time t equal to 0, the particle's velocity points in the x direction. That's true, because at t is equal to 0, what we see is that by this equation, Vy is equal to 0. Okay, so therefore the particle's velocity points in the x direction always. That is also true. So B is also true, C is also true. Ax equal to 0 implies that t equal to 1 second. The angle between the particle's velocity and the x-axis is 45 degree. Okay, Ax is equal to 0 implies that at t equals 1 second. Okay, the angle between the particle's velocity and the x-axis is 45 degree. You see Ax is 0 and Vx is 1 meter per second. So therefore t is equal to 1 second, x is going to be 1. So therefore Vy is equal to x Vx. Now x is 1, so therefore Vy is equal to Vx, so therefore the angle is going to be 45 degree. So therefore D is correct. Thank you.
A particle of mass m is moving in the xy plane such that its velocity at a point xy is given as v is equal to, okay, so v is equal to alpha y I cap plus 2x j cap. What is the force F acting on the particle? So if you can see here, Vx हो गया alpha I and Vy is 2 alpha x. So now if V is this, so therefore acceleration becomes, which is dv by dt, this becomes alpha into dy by dt I cap plus 2 into dx by dt j cap, which is alpha into dy by dt is actually vy I cap plus 2 into vx j cap. Now we already know vx and vy, so this is alpha into vy, which is 2 alpha x I cap plus 2 alpha into Vx, which is again alpha into y j cap. So this is the acceleration. So therefore the force will become mass into acceleration, which is m into 2 alpha square x I cap plus y j cap, which is option A. Thank you. A slide with a frictionless curved surface which becomes horizontal at its lower end. Okay, so this is the curved surface, is fixed on the terrace of a building of height 3h from the ground. Okay, as shown in the figure. A spherical ball of mass m is released on the slide from rest at a height h from the top of the terrace. Okay, the ball leaves the slide with a velocity u naught I and falls on the ground at a distance d from the building, making an angle theta with the horizontal. It bounces off with a velocity v and reaches a maximum height h1. The acceleration due to the gravity is g, and the coefficient of restitution of the ground is 1 by root 3. Which of the following statements are correct? Okay, so now u naught. So let us find u naught. U naught is simply, so if you see doing work energy power, so energy conservation, so half m u naught square is equal to mgh. So u naught becomes simply root over 2 gh I cap. So yes, option 1 is correct. Now it is striking here and then it bounces off with a velocity v. So when it is striking, so now if you see, this velocity is not going to change, but let us talk about this velocity. So here uy is 0 and s is 3h. Okay, so here we can apply the equation s equals ut plus half, it is v square equals u square plus 2gs. So final velocity in y direction 0, initial velocity was 0 plus 2 into g into 3h. So the final velocity becomes root over 6 gh. So when it is striking, it has the velocity like this, root 2gh, and in this direction it is root over 6 gh. So if this is theta, we can see tan theta is equal to root over 6 gh by root over 2 gh, which is root 3. So therefore theta is 60 degree. That is, so second option is also correct. Okay, first was correct, second is correct. Now here it is mentioned d by h1 is equal to 2 by root 3. Okay, so now again the coefficient of restitution is 1 by root 3. Okay, and the velocity here before striking, it's root 2gh, and in this direction it's root 6gh. So because of colliding and then going up, so E will become velocity of separation or velocity of approach. So velocity of separation, let us say Vy, velocity of approach was root 6gh, and E is 1 by root 3. So Vy becomes, it's not 2, Vy becomes root over 2gh. So therefore h1 is going to be, okay, so here the velocity in y direction is going to be 0. So therefore and the initial velocity was in y direction root 2gh. So Vy square equals uy square plus 2gh. So root over 2gh whole square divided by 2g. So basically this is h. So h is equal to h1. h1 equals to h. Now d. Okay, so what was the time, how much time it took to come from here to here? So time can be calculated by s equals ut plus half at square. So 3h is equal to, initial velocity was 0 here, so half into g into t square. So t becomes root over 6h by g. So therefore d will become root over 6h by g into the velocity in this direction, it was root 2gh, root 2gh. So g is gone. This is actually root over 12 into h. Okay, so now this is d. So d by h is actually root 12, which is 2 root 3. So yes, this is also correct. So this is correct, this is correct, this one you had already found correct. And what is this? V, k. Okay, okay, we have to write k. But okay, now after collision is the velocity v is bounces off. When it is bouncing, it has to be upward direction. Now here they have taken it to be z direction, so it has to be positive, it cannot be negative. So B is not an option. A, C and D are the correct options. Thank you. Person of height 1.6 meters walking away from a lamppost of height 4 meters along a straight path on the flat ground. So this is lamppost, is 4 meter height, and this is the person, which is 1.6 meter height. This is the shadow. This is the shadow, and the lamppost and the person are always perpendicular. Okay, the speed of the person is 60 centimeter per second. So the person is actually going by, so let us say v1 is 60 centimeter per second. The speed of the tip of the person, so what is going to be v2? Okay, fine. So let this be x1 here, and let this be x2. So if you see, by similarity of triangle, 4 by 1.6 becomes x2 divided by x2 minus x1. This goes as 2.5. 2.5 x2 minus 2.5 x1 is equal to x2. So 1 x2 into 1.5 is equal to 2.5 x1. So therefore x2 becomes, that is 5 by 3 into x1. Differentiate on both the sides. So dx2 by dt, which is actually v2, becomes 5 by 3 into dv1 by dt, dx1 by dt, which is 60. It goes as 20. So 100 centimeter per second is this velocity. However, it's mentioned here the speed of the tip of the person's shadow on the ground with respect to the person. So velocity of tip is 100, velocity of person is 60. So velocity of tip with respect to person becomes 100 minus 60, which is 40 centimeter per second. So 40 is the answer. Thank you.
Projectile is fired from horizontal ground with speed v. ठीक है, ये स्पीड v से इसको फायर किया गया है, एंगल हो गया इसका थीटा. When the acceleration due to gravity is g, the range of the projectile is d. ठीक है, तो एक्चुअली ये ऐसा जाएगा, ये प्रोजेक्टाइल कुछ ऐसा जाएगा. नाउ रेंज ऑफ प्रोजेक्टाइल इज d, सो d क्या हो जाएगा, v स्क्वायर साइन 2 थीटा डिवाइडेड बाय g. दिस इज d. ये पहला चीज़ है, हम लोग लिख लिए. ओके, if at the highest point in its trajectory the projectile enters a different region where the effective acceleration due to gravity is g dash equals 0 g by 0.8. तो यहाँ पे which is at the maximum height, तो ऑलरेडी ये कितना कवर कर चुका है, ये ऑलरेडी d by 2 कवर कर चुका है. ठीक है, एंड कितना ऊपर है ये, सो मैक्सिमम हाइट इज v स्क्वायर साइन स्क्वायर थीटा बाय 2g है. ठीक है, अब देखिए यहाँ पे इसका वेलोसिटी है इस डायरेक्शन में v कॉस थीटा. ठीक है, क्योंकि जो वर्टिकल वेलोसिटी है दैट हैज़ बिकम 0, सो v कॉस थीटा, एंड वर्टिकल वेलोसिटी इज 0. Initial velocity in y direction is going to be 0. अब इसको यहाँ से यहाँ आने में कितना टाइम लगेगा ये हम लोग कैलकुलेट कर लेते हैं, ठीक है। सो दिस इज h, so this is equal to half at square, so v square sin square theta divided by 2g should be equal to half into, अब यहाँ पे एक्सेलरेशन हो गया है g dash which is z divided by 0.81 into t square, so half is gone, so therefore time becomes v sin theta by g into root over 0.81 which is 0.9 into v sin theta divided by g, ठीक है। इतना टाइम अब लगेगा इसको नीचे आने में, और उतने देर में ये v cos थीटा से ट्रैवल कर रहा है इस डायरेक्शन में, ठीक है। तो हम लोग लिख लेते हैं v cos थीटा इंटू कितना 0.9 इंटू वी साइन थीटा बाई जी, 0.9 इंटू वी साइन थीटा डिवाइडेड बाई जी, तो कितना हो गया ये हो गया 0.9 वी स्क्वायर साइन 2 थीटा डिवाइडेड बाय 2g, ओके। सो दिस इज द डिस्टेंस, है ना। अगर हम लोग ये बोलें कि दिस इज r1, this is r2, so r1 was d by 2 and r2 is this is r2 which is equal to actually 0.9 into ये क्या है d by 2 है, ठीक है। सो देयरफॉर टोटल जो रेंज हो जाएगा वो हो जाएगा d by 2 प्लस d by 2 into 0.9 which is 0.95 इंटू डी, ठीक है। तो वैल्यू ऑफ n क्या हो गया 0.95 हो गया, ठीक है। पर फिर से हम, है ना, हम लोग रिकैपिटुलेट कर लेते हैं, देखिए ध्यान से यहाँ पे हम लोग, है ना। सो फ्रॉम हियर हाउ वी कैलकुलेट r2, ठीक है। तो यहाँ पे वेलोसिटी तो जीरो है ना, पर एक्सेलरेशन इस डायरेक्शन में हो गया g डिवाइडेड बाय 0.81, ठीक है। तो s इक्वल्स यूटी प्लस हाफ एटी स्क्वायर हम लोग को पता है। सो s व्हाट इज द डिस्टेंस, दिस इज द डिस्टेंस, u इज 0, हाफ एटी स्क्वायर, तो ये हम लोगों ने किया, दिस इज s हाफ a t स्क्वायर। तो इससे हमको टाइम पता चल गया कितने टाइम में, इन हाउ मच टाइम द बॉल विल टेक टू रीच दी ग्राउंड, ठीक है। तो ये जो टाइम पता चल गया हमारा 0.9 इंटू वी साइन थीटा बाई जी। अब इस इतने टाइम में x डायरेक्शन में तो वेलोसिटी इज v cos थीटा, सो देयरफॉर व्हाट वी डिड वाज वी टुक द टाइम एंड वी मल्टीप्लाइड with the velocity in x direction, and thus we got r2 which is equal to 0.9 into d by 2. Now already it has traveled d by 2 previously, so therefore the total is going to be d by 2 plus 0.9 into d by 2 which becomes 0.95 into d, and that's what is the answer. Okay, कभी कभी स्टूडेंट्स गलती कर सकते हैं, क्या गलती कर सकते हैं ये भी हम लोग पॉइंट आउट कर देते हैं। यहाँ पे देखिए, यहाँ तक हम लोगों ने जो कैलकुलेट किया है वो क्या कैलकुलेट किया है, वी स्क्वायर साइन 2 थीटा बाई जी था, है ना, जो कि पूरा रेंज था, ठीक है। तो दिस इज वी स्क्वायर साइन 2 थीटा बाय 2g हो गया ये यहाँ तक। और यहाँ पे कभी कभी स्टूडेंट्स यहाँ पे गलती कर सकते हैं, बोल सकते हैं वी स्क्वायर साइन 2 थीटा बाय 2g डैश कर सकते हैं, जो कि गलत हो जाएगा। क्यों गलत होगा, बिकॉज, है ना, एट द हाईएस्ट पॉइंट अगर g डैश रहता तो उसका हाईएस्ट पॉइंट विल नॉट बी दिस, वो 2g डैश रहता, ठीक है। तो इसीलिए कभी कभी स्टूडेंट्स गलती कर सकते हैं। ओके, थैंक यू वेरी मच। A projectile is thrown from the point O on the ground at an angle 45 degree from the vertical with a speed 5√2 मीटर पर सेकेंड, ठीक है। तो ये जो है 5√2 मीटर पर सेकेंड से थ्रो किया गया है and this is 45 degree. So therefore in this direction it's 5 meter per second, and in this direction it's again 5 meter per second. The projectile at the highest point of its trajectory splits into two equal parts. At the highest point it splits into two equal parts. One part falls vertically down to the ground. This is the one part, and two equal parts. Okay, so if this was m, so this is m by 2. Okay, so therefore now the second part m by 2. Okay, the second part m by 2. So now m by 2 कैसे जाएगा? तो यहाँ पे we have to do conservation of momentum. Okay, so we will write down. So this was m, which was going with velocity of 5, because at the highest point vertical velocity 0 हो चुका है, तो ये 5 से जा रहा है, and now it breaks into two halves. ठीक है, which is m by 2 and this is also m by 2. Now this has no velocity, that's why it's going to fall vertically down. So इसका 0 है velocity. So this should go with a velocity of 10 meter per second based upon conservation of momentum, because m into 5 should be equal to m by 2 into 0 plus m by 2 into v. So therefore v हो गया 10 meter per second. Okay, so now this is going with velocity of 10 meter per second. Okay, so one part falls vertically to the ground 0.5 second after the splitting. The other part t seconds after the splitting falls to the ground at a distance x meters from the point O. The acceleration due to gravity is g. G is 10. What is the value of t? T को find out करना है और हम लोग x को भी find out कर लेंगे. Okay, fine. तो देखिए ध्यान से, ये यहाँ पे जो पहुँचा है ना, तो what is the like you know highest point पे ना, like h max is equal to u square sin square theta by 2g. So u square, so 5 into 5 into 2 u square into sin square theta 1 by 2 divided by 2 into g. Okay, so it's 25 divided by 20. So this is 1.25 meter hai. Okay, fine. Now what is the time taken to fall? So half into 10 into t square should be equal to 1.25. So therefore t square becomes 2.5 divided by 10. T square becomes 0.25. So therefore t is 0.5 seconds, जो कि हमारा यहाँ पे भी निकला हुआ है 0.5 seconds. Okay, now for this part, okay, like we just validated, and now for this part which is m by 2 and is going with a velocity of 10 meter per second. So we can see that t seconds after the splitting it falls to the ground and at distance x. तो इसका भी इस डायरेक्शन में तो वेलोसिटी 0 ही है ना, ठीक है. So this will also take how much? 0.5 seconds only to fall. And how much distance it will travel? So it will travel 0.5 into 10, which is 5 meters. It's going to travel from here. Okay, so now अभी तक ये already कितना travel कर चुका है? Let us calculate this. So it has traveled range by 2, which is u square sin 2 theta by g. So 5 into 5 into 2 into sin 2 theta, which is 1, by g, which is 10, into 1 by 2. So this is 2.5 meters. So already 2.5 meters it has traveled. So the value of t is 5 seconds because after the splitting, and distance x meters from the point O. ठीक है, तो यहाँ से ये 5 मीटर ट्रेवल किया था और ये ऑलरेडी 2.5 मीटर है, so therefore it is going to travel 7.5 meters. This is x. Okay, thank you. Electric field that is 400 root 3 is applied in a region. Okay, ये uniform electric field applied है. Charge particle of mass m carrying positive charge q is projected in this region with this much speed. The particle is aimed to hit at a target t, which is 5 meter away from its entry point into the field as shown schematically in the figure. Take q by m is this much, then. So fine. So देखा जाए ध्यान से तो इस चार्ज पार्टिकल पे जो फोर्स लगेगा दैट इज q इंटू ई, तो एक्सेलरेशन हो जाएगा क्यू ई डिवाइडेड बाई एम. सो दिस इज गोइंग टू बी द एक्सेलरेशन इन दिस डायरेक्शन. सो क्यू इज, वी डोंट नो, क्यू बाय एम वी नो, सो दिस इज 10 into the power 10 into e. E is 400 root 3. Okay, so this becomes 4 root 3 into 10 to the power 12 meter per second square. This is acceleration. ठीक है, so now sometimes we may feel कि g भी include कर लेते हैं, लेकिन इतना ज़्यादा acceleration है 10 to the power 12, so just adding 10 or subtracting 10 is not going to make any difference, much difference. Okay, so now the particle will hit t. Okay, so for the particle to hit t, what we are proposing is, what we understand is the range should be 5 meters. Okay, so now let us calculate u square, okay, sine 2 theta by g. Okay, and the g will be the acceleration because it's in downward direction. Okay, so the range, so 5 meter is going to be u square sine 2 theta by g. What is u? U is 2 root 2 into 10 power 6. So this becomes 2 into 2 into 10 into 10 to the power 12. Okay, u square sine 2 theta divided by g. Now g is this 4 root 3 into 10 to the power 12. Okay, so 10 to the power 12, 10 to the power 12 is gone, 2 is gone, and this becomes 2. So therefore sine 2 theta becomes root 3 by 2. Now sine 2 theta is root 3 by 2. Okay, so let us see the graph of sine. Okay, so sine 2 theta is root 3 by 2, so therefore the theta should be, okay, so 2 theta can be either 60 degree or 2 theta can be 120 degree. Okay, तो ये गलती मत कीजिएगा कि 2 थीटा को केवल 60 डिग्री लिखना. ठीक है, so we write 2 theta should be either pi by 3 or 2 pi by 3. So therefore theta becomes 60 degree divided by 2, 30 degree or 60 degree. दोनों में range उतना ही आएगा. So A is wrong but B is correct because it is project at either 30 degree or 60 degree. Now the time taken, so T, तो T कितना हो जाएगा, 2u sin theta by g, 2 into u is 2 root 10 into 10 to the power 6 divided by g, which is 4 root 3 into 10 to the power 12, और ये साइन थीटा, तो एक बार हम लोग को साइन थीटा में साइन 30 लेना है विच इज़ 1/2 और साइन 60 विच इज़ रूट 3/2. तो करते हैं, ये 4 से 4 चला गया, दिस बिकम्स 10 to the power 6. Okay, so it is either root 10 by root 3 into 1/2 mu seconds. Okay, 2u sin the, okay, or it is root 10 by root 3 into root 3 by 2 mu seconds. So what is it? So this becomes uh, this is 2, so this 5 and this becomes root 2, so therefore root 5 by 6 mu seconds, or this is gone, this is root and this is 5, so this is root 5 by 2 mu seconds. So we match the answer with C. D is not the answer, so therefore B and C are the correct answers. Okay, so this is again a simple question of projectile. Okay, what we have to do is simply we have to just take care that the acceleration है ना, तो acceleration क्या है, QE by m. So therefore because Q by m is already given here, okay, तो therefore हमको acceleration आसानी से आ जाएगा, और वो जो acceleration है वो नीचे के तरफ है. So now this acceleration takes the role of the g which was in our projectile before, and everything, all the formulas will be the same. Only thing is you replace the g by this acceleration a. Okay, thank you. Ball is thrown from ground at an angle theta with the horizontal with initial speed u0. For the resulting projectile motion, magnitude of the average velocity of the ball up to the point when it hits the ground for the first time is v1. After hitting the ground, the ball rebounds at the same theta but with reduced speed u0 by alpha. Its motion continues for a long time as shown in the figure. If the magnitude average velocity of the ball for the entire duration of motion is 0.8 v1, the value of alpha is, okay, so ball is okay. So average velocity कैसे निकालते हैं? Total displacement divided by total time. Okay, तो पहला के लिए like for the first for this motion, okay, this is the first time it hits the ground again, this is the second time, this is the third time, and so on. So the first time if you see, then the range is going to be, because that is going to be the total displacement, so range is u0 square sine 2 theta divided by g, and the time taken is 2u sine theta upon g. Okay, so this is the average velocity, so g is gone. Okay, u0 is gone, so this becomes 2u0 sine theta cos theta divided by 2 sine theta, so basically this is u0 cos theta. Okay, now for this is for the first one, so for the second one it's going to be u0 by alpha cos theta. This is the average velocity. Now what has to be found out is if the magnitude of the average velocity of the ball for the entire duration of motion is 0.8 v1. Okay, so now average velocity we know. So now what we have to do is basically we have to now, okay, so this is for the first one, this is for the second one, but now we don't have to calculate for each and every one, we have to calculate for all together everything. So therefore it's going to be total displacement. So therefore u naught square sine 2 theta by g plus u naught square by alpha square into sine 2 theta by g and so on, divided by, so this is going to be the average velocity, divided by 2 u naught sine theta by g plus 2 u naught by alpha into sine theta by g and so on. So therefore what we do is u naught sine 2 theta by g, and that becomes 1 plus alpha square and so on. This is going to be 1 by alpha 4 and so on, divided by 2 u naught by g into sine theta into 1 plus 1 by alpha plus 1 by alpha square and so on. Okay, so this becomes, so g is gone, u naught, this is gone, this is 2 sine theta cos theta, so sine theta and sine theta is gone, 2 is gone, so u naught cos theta. So this is this becomes u naught cos theta sorry, and 1 plus 1 by alpha whole square and all. Okay, so this becomes a by 1 minus r to the power n alpha square. Okay, now because this is infinity, so that's why we are taking this into again 1 divided by 1 minus 1 by alpha. So this becomes u naught cos theta into this is 1 divided by 1 plus 1 by alpha. Okay, now okay, the magnitude of average velocity of the ball up to the point when it hits the ground first time, v1. So v1 is actually u naught cos theta. Okay, so therefore this whole thing is going to be 1 by 1 plus 1 by alpha is going to be 0.8. So therefore 1 plus 1 by alpha is going to be, so this is 10, this is 4, this is 5, it's going to be 1.25. 1 by alpha is going to be 0.25, so alpha is going to be 4, therefore the answer is going to be 4. Okay, so again I will explain what we have done here. So total displacement divided by total time. So this is displacement 1, this is displacement 2, this is displacement 3 and so on. So if we see the total displacement, okay, so this is d1 u naught square sine 2 theta by g, this is u naught square by alpha square, because here the u naught has decreased by alpha, so alpha times it has decreased, so therefore this formula comes, and this is again for the time period. So therefore when we add the total displacement, and this is going to be the total time taken, and therefore we get this entire thing. Thank you. A ball projected from the ground at angle 45 degree with the horizontal surface. Okay, 45 degree, then velocity v, it reaches a maximum height of 120 meter. Okay, so that means we can write v square sine square theta by 2g, which is the maximum height, is going to be 120 meters. So therefore this becomes v square sine square theta is 1 by root 2 into 1 by root 2 is going to be 1 by 2 into 1 by 20 is equal to 120 meters. Okay, so v square becomes 1200 into 4. Okay, forget me to, because like everything is standard unit, so you need not worry. So this becomes 2 into 10 into 2 into root 3. So this is 40 root 3 meter per second. This is V. Now it is said that after it hits, then so kinetic energy becomes half. So therefore half into m into v square divided by 2 should be equal to half into m into velocity nu whole square. Okay, so therefore velocity nu becomes v, okay, this is gone, v upon root 2, which is let us write 40 root 3 by 2 meter per second. Now it is written here that now it makes an angle 30 degree with the horizontal surface. So therefore the new maximum height is going to be Vn square sine square 30 degree divided by 2g, which is 40 into 40 into 3 divided by 2 into sine 30 is 1 by 2, 1 by 2 into 1 by 2 divided by 1 by 2 into 10. So this is 4 into 10, 40 is gone, 2 into 2 is 4, so 10, so this becomes 30 meter. So therefore now the maximum height which is going to reach is going to be 30 meters. Thank you. Three vectors P, Q and R as shown in the figure. Let S be any point in the vector R. Okay, so this is S. The distance between points P and S is B and magnitude of, okay, B into magnitude of R. The general relationship between, okay. So here we can write that P vector plus PS vector is equal to S vector. Now P vector plus PS vector, the magnitude of PS vector is B into mod R, and for the sense of the direction, okay, so if you see this PS vector is in this direction, and in the same direction its R vector is also there. Okay, so therefore we can write PS vector as the magnitude of PS vector is B into mod R into R cap. Okay, so now BS into R cap, which is a unit vector in R direction. So therefore this becomes P vector plus, now if you see R vector into mod R, okay, so this is going to be R vector itself. Okay, because R cap is equal to R vector mod R. So therefore this becomes P plus B R vector, which is equal to S vector. Now R vector is given as Q minus P. Q minus P is equal to S vector. So therefore we can write S vector is equal to P vector 1 minus B plus B Q vector, which is C option. Thank you. Okay, so this is the situation. A is going with a velocity of 100 root 3 meter per second at 30 degree, and A is at some height. B is also at some other height. The distance between them is 500 meter, and the velocity of B is at 60 degree with respect to the horizontal. So now what A is observing, the A is observing that B is coming directly to him because A just escapes being hit by B. So almost, it's in this direction only, and at the same time it is moving at a constant velocity perpendicular to the line of the motion of A. So therefore we can see that velocity of B with respect to A is perpendicular to velocity of a, sorry. Okay, तो कुछ ऐसा है. Okay, so velocity, so if this is 30 degree, this is going to be 60 degree, and therefore this is also going to be 60 degree. So therefore velocity of B with respect to A is going to be in such a manner, okay, where the net velocity is going to be 60 degree. Okay, so now we should write velocity of B with respect to A. This is going to be velocity of B minus velocity of A, which is V cos 60 I cap plus V sin 60 j cap minus velocity of A 100 root 3 cos 30 degree, which is root 3 by 2 A cap, plus 100 root 3 to sin 30 degree 1 by 2 j cap. So this is going to be V by 2 minus, this goes as 50, minus 150 I cap plus V root 3 by 2 minus 50 root 3 j cap. Okay, so therefore now we can see in, so the velocity of B with respect to A. Okay, so what A is observing, B is coming in this direction. Okay, so this is I cap, so this is going to be in minus I cap, it's going to be 150 minus V by 2, and in this direction it's going to be V root 3 by 2 minus 50 root 3. So it's going to be 60 degree, so therefore tan 60 degree is going to be root 3, which is equal to V root 3 by 2 minus 50 root 3 divided by 150 minus V by 2. So root 3 is gone, so 150 minus V by 2 is equal to V by 2 minus 50. So therefore V becomes 200 meter per second. So therefore the velocity of B is 200 meter per second, and velocity of B with respect to A is, velocity of B with respect to A is, so this is so this is minus 50 I cap plus, so 100 root 3, so this is 50 root 3 j cap. Okay, so now if we see that, so it's going to be something like this. In this direction it's 50, and in this direction it is 50 root 3. So therefore in this direction, the resultant is going to be root over 50 square plus 50 root 3 whole square, which is equal to 50 into 2, which is 100 meter per second. Okay, so therefore B is being, B is approaching A with a speed of 100 meter per second, and the distance initial is 500 meters. So therefore the time t0 is going to be 500 meter divided by 100 meter per second, which is 5 seconds. So therefore 5 seconds is the answer. Okay, so again I will explain how we started with. So we started with simple, we took A, okay, and we took B at and these both are at some height here. Okay, now B is going in some direction, A is also going in some direction, but the velocity of B with respect to A, as it is mentioned, it is perpendicular to the line of the motion of A. So therefore what we do is we assumed some velocity, and then we calculated velocity of B with respect to A. This entire thing we calculated, and this comes out to be this. Now since it is mentioned that it is perpendicular, so we know the direction of it. Okay, so 60 degree. So 60 degree is Vy divided by minus V of x. So therefore we have put a negative sign over here. Okay. Velocity comes out of B is 200. The velocity of B with respect to A in this direction, it comes out to be 100 meter per second. So therefore, since it is at 500 meter, so 500 divided by 100 is going to be 5 seconds. Thank you. Rocket is moving in a free gravity free space. Okay, तो इसमें हम लोग क्या करेंगे? We will put the person here as the observer. Okay, and then he is seeing. Okay, so the person is there at the origin. So therefore वो जो है A को कैसे देखता है? A का velocity is in this direction 0.3 meter per second and there is a pseudo force on A which causes acceleration of 2 meter per second square in the negative direction. So therefore we can write the coordinate of A as 0.3t minus half into 2 into t square. This is first, and this is what? This is the x coordinate of A. Okay. For B, we have velocity is in this direction 0.2 and acceleration is also in this direction, which is 2 meter per second square. This acceleration is due to the pseudo force. So therefore coordinate of B is equal to minus 0.2 t minus half into 2 into t square, and because it was already present at 4 meter before, so therefore plus 4 meter. This is second. Now for both the coordinates to be the same, okay, that's when the collision is going to happen. So therefore we put xa should be equal to xb. Now what happens is 0.3t minus half into 2 into t square should be equal to minus 0.2t minus half into 2 into t square plus 4. So this and this is gone. Therefore it becomes 0.5t is equal to 4. So therefore t is equal to 8 seconds. Now the question isn't over. So now if we calculate in t equal to 0 in 8 seconds where the ball A goes, okay, we are taking this as A and this is B. So if we see where the ball A goes, so x coordinate of A becomes 0.3 into 8 minus half into 2 into 8 into 8 is gone. So therefore it becomes 2.4 minus 64. So therefore this is minus 61.6 meters. Now there is no way that A can go to minus 61.6 meters. So therefore this 8 second is actually little vague. Okay. So therefore what we will do is, okay, the better answer what we can say is that let us assume that this A ball, okay, this A ball, so basically how this A ball goes is this A ball goes like this and then it comes back and that's how it goes negative direction. So let us assume that the A ball when it comes here it sticks here. Okay, we have to assume it because nothing is given in the question. Okay, so therefore now what has to be done is just the B ball has to travel this 4 meters. So therefore 0.2t plus half into 2 into t square is equal to 4. Okay, so therefore is 5t square plus t minus 20 is equal to 0. So therefore t becomes nearly is equal to 2 seconds in this. If you calculate this, you'll get it around 1.9 and all. So it becomes almost nearly equal to 2 seconds. Okay, and that's what is given as the answer in the standard textbooks. Now one more thing which can happen is, okay, see, because nothing is like mentioned, so therefore we can, like, we can write. So a, it goes like this and then it comes back. So when it comes back here again, there can be rebounds happening. Okay, now that goes in a little more of this goes in little more of what do you call, little more of calculations and all. Okay, so this part I have seen all the standard textbooks also have avoided it. Okay, but now the point is that on one hand we are getting 8 seconds and on the other hand we are getting 2 seconds. Better is to go with 2 seconds because the otherwise it will go out of the rocket. Okay, again the length of the chamber, it's a chamber, so it should be close, it should not go out of the rocket. Thank you.
A particle of mass m is projected from the ground with an initial speed u naught. So this is mass m, it is u naught, and at an angle alpha with the horizontal at the highest point of its trajectory. highest point of trajectory पे इसके पास जो velocity है that is u naught cos alpha, क्योंकि vertical direction का velocity तो 0 हो गया है, that's why it's the highest point, and mass is m with the horizontal. At the highest point, it makes a completely inelastic collision with another identical particle which was thrown vertically upward from the ground with the same initial speed u naught. तो ये ग्राउंड से u naught स्पीड पे फेंका गया है. अब देखिए ध्यान से, दिस इज द मैक्सिमम हाइट विच इज u naught स्क्वायर sin square alpha divided by 2g. So now this is a, this is b. So therefore ये b वाला जो मास m है, in order to reach here, यहाँ पे जब वो पहुँचा तो उस समय उसका velocity कितना है, what is its velocity, let us find out. So for b we are calculating, so v square equals u square plus 2as. So final velocity is v square, initial velocity was u naught square plus 2as plus 2 into acceleration is minus g into s is u naught square sin square alpha divided by 2g. Gone. So v square is u naught square 1 minus sin square alpha, which is u naught square cos square alpha. So therefore v becomes u naught cos alpha. So therefore now let us go for the collision. So now this a particle mass m, and this is u naught cos alpha in this direction, and there is a b particle which is having again mass m and it is having u naught cos alpha in the upward direction. So therefore after the collision the total mass becomes 2m. So therefore in this direction it is u naught cos alpha divided by 2. In this direction again it's u naught cos alpha by 2. Okay, so therefore it will be going at an angle of 45 degree, which is pi by 4. Okay, now one common mistake which students may do is like they may consider, okay, so this is going with u naught and at an angle alpha, so here it's like u naught cos alpha. Okay, so now the time taken for it to reach here is 2u sin theta by g divided by 2, so therefore u naught sin alpha by g. And what students may do, a common mistake is they may assume that this u naught after reaching, like here it has already traveled time t and therefore we can calculate the velocity, but that will not work because this is not thrown at the same time when A was thrown in the air at an angle alpha, because obviously this ball B is going to uh, go at a, okay, a small block is connected to one end of a massless spring of unstretched length 4.9 meters. Okay, the 4.9 meter पे है. The other end of the spring is fixed. The system lies on a horizontal frictionless surface. Block is stretched by 0.2 meter. So the amplitude is going to be 0.2 meters and release from rest at t equal to 0. तो basically ये यहाँ पे release हुआ है. This is the position at t is equal to 0 and this amplitude is 0.2 meters. Okay, तो अब जो है it then executes SHM with angular frequency pi by 3 radian per second. So time period कितना हो गया? 2 pi by 3 which is 6 seconds. This is the time period. तो एक पूरा घूमने में इसको 6 सेकंड लगेगा. Simultaneously, a small pebble is projected, okay, from an angle 45 degree. Point P is at a horizontal distance of 10 meters from O. If the pebble hits the block at t equals 1 second, तो 1 सेकंड में ये कितना जाएगा? See, 6 seconds it's going 360 degrees. So therefore in 1 second it's going to go 60 degrees. So therefore it's 0.2. So this is going to be 0.2 cos 60 degree, which is 0.1 meters. ठीक है. So this is तो ये कितना था? 4.9 मीटर था और इससे 0.1 मीटर. So therefore at 5 meter the pebble is going to hit. ठीक है, when it is at 5 meter. So now this है ना, कुछ ऐसे हिट करेगा ये. ठीक है. So now if you see the velocity of the pebble in this direction is v cos 45. So this is v by root 2 and time is 1 second and the pebble has to travel 5 meters. So therefore this is 5 meter. So therefore v becomes 5 root 2, which is root over 50 meter per second. This is A. A is the option. Okay, ये वाला ऑप्शन. ओके, एक बार फिर से हम लोग समझ लेते हैं कि कैसे हम लोगों ने क्या क्या किया है. तो सिंपल है. देखिए, दिस ब्लॉक इज गोइंग टू डू SHM लाइक दिस. ओके, तो यहाँ से ये रिलीज हुआ है. सो 4.9 था ऑलरेडी. नाउ 0.2 मीटर इज स्ट्रेच्ड, सो दिस बिकम्स 5.1 मीटर. ठीक है, और ये है 4.9 मीटर. नाउ एट t इक्वल टू 1 सेकेंड ये कहाँ पे रहेगा? सो दिस गोज 0.1 मीटर इनसाइड. सो देयरफॉर 5 मीटर पे ये ब्लॉक है एट t इज इक्वल टू 1 सेकेंड पे. ठीक है. सो नाउ अब यहाँ पे दिस पेबल इज गोइंग टू स्ट्राइक. सो देयरफॉर दिस द हॉरिजॉन्टल वेलोसिटी ऑफ द पेबल इन दिस डायरेक्शन इज v cos 45, that is v by root 2. तो वही हमने किया, v by root 2 into time and it has traveled 5 meters. So therefore we will get v. Thank you. A train is moving along a straight line. ठीक है, ये है ट्रेन, ये मूव कर रहा है along a straight line with a constant acceleration a. A boy standing in the train throws a ball forward with a speed of 10 meter per second at an angle of 60 degree to the horizontal. ठीक है, तो ये हो गया 10 मीटर पर सेकेंड at an angle 60 degree with the horizontal. ठीक है. So now this is with respect to the train. ठीक है, तो अगर ट्रेन का वेलोसिटी मानिए v था, तो इस बॉल का वेलोसिटी जो है ना, इस डायरेक्शन में हो जाएगा 10 cos 60 degree plus v, and in this direction it's going to be 10 sin 60 degree. So this becomes 10 root, so 5 root 3, and this becomes v plus 5. Okay, now the boy has to move forward by 1.15 meter inside the train to catch the ball back at the initial height. अब ये ball जो है ऐसे जाएगा, it moves, okay, here, okay, and this is somewhat it moves. So initially the person was standing here, now he has to move how much? 1.15 meters to catch the ball. So time taken ना, कितना टाइम बॉल रहा एयर में? So this is 5√3. So 2 into 5√3 divided by g. So this is √3 seconds. Okay. Now the ball is not having any acceleration a in the forward direction because it has left the train. So therefore we can write that how much the ball is going to move ahead is, so the displacement of ball in x direction is going to be v plus 5 into √3. There is no acceleration. Now for the train moves in x direction with v into √3 plus half into a into √3 whole square. Okay, so that is √3v plus 3a by 2. Okay, that much the train moves. Now the ball travels an extra 1.15 meters. So therefore v plus 5 into √3 should be equal to √3v plus 3a by 2 plus 1.15 meters. So therefore this is going to be 5√3 is equal to 3a by 2 plus 1.15, 1.15. Okay, so this is going to be a is going to be 5√3 minus 1.15 divided by 1.5. Okay, so the acceleration of the train is going to be something like this. So we have to calculate the entire thing. So √3 is 1.73. So this becomes 5 into 5. So this becomes 5, 6, 3 is remaining. So this is 8.65. So 8.65 minus 1.15 divided by 1.5. So this is 7.5 divided by 1.5, that is 5. So acceleration is going to be 5 meter per second square. Thank you. For an observer looking out through the window of a fast moving train, the nearby objects appear to move in the opposite direction to the train, while the distant objects appear to be stationary. Yes, this is because of angular velocity. Okay, like for example, so this is a train moving, okay, and this object comes here, whereas this object comes here. Okay, so we see that this object is having is covering its a greater angle than the distant object. Okay, because the angle covered is less. So therefore the distant object appears to be stationary, or it appears to move with less velocity because the angle with what it moves is less. Okay, so first statement 1 is true. Okay, and the reason being angular velocity is less. Statement 2, if the observer and the object are moving at velocities v1 and v2 respectively with respect to a laboratory frame, the velocity of the object with respect to the observer is, so that is v2 minus v1, that is quite true. This is observer is moving with velocity v1 and object is moving with velocity v2. This is a, this is b. So velocity of the object with respect to observer is going to be v2 minus v1. That's true. However, that is not the correct explanation for statement 1, because the correct explanation for statement 1 is, as I said, that it's the angular velocity covered is, like, angular velocity is less. Okay, thank you. On a frictionless horizontal surface assumed to be xy plane, a small trolley A is moving along a straight line parallel to the y-axis. Okay, it's moving parallel to the y-axis. Fine. With a constant velocity root 3 minus 1 per second. Okay. At a particular instant, the line OA makes an angle of 45 degrees with the x-axis. A ball is thrown along the surface from the origin O. Its velocity makes an angle phi with the x-axis and it hits the trolley. So obviously it will be, something like this. The ball is going with let us say velocity v, and this is phi. The motion of the ball is observed from the frame of the trolley. Calculate the angle theta made by the velocity vector of the ball with the x-axis in this frame. Okay, and find the speed of the ball with respect to the surface if phi is equal to 4 theta by 3. Okay, so we can write that the velocity of A is actually root 3 minus 1 j. Velocity of ball is v cos phi I cap plus v sin phi j cap. So therefore velocity of ball with respect to A is v cos phi I cap plus v sin phi minus root 3 plus 1 j cap. Okay, so angle theta made by the velocity vector of the ball with the x-axis in this frame. So therefore tan theta becomes v sin phi minus root 3 plus 1 divided by v cos phi. Okay, and yes, it's going to hit the trolley. So therefore we can write that the line OA makes angle of 45 degree with the x-axis. Okay, so that means what? That initially this is A and this is also A. So therefore v cos phi into t is going to be equal to A, and v sin phi into t is going to be A plus root 3 minus 1 into t. Okay, so therefore here we can see that v sin phi minus root 3 plus 1 is equal to A by t, and v cos phi is also equal to A by t. So therefore this is 1. So theta is going to be equal to 45 degrees. Okay, find the speed of the ball with respect to the surface if phi is equal to 4 theta by 3. Okay, so 4 theta by 3 is equal to 4 by 3 into 45, which is equal to 60 degrees. So therefore speed of the ball with respect to the surface. So basically we have to find v. Okay, so therefore we can write v into cos phi is A by 2. Cos 60 is 1 by 2 is equal to a by t, and v sine phi is v sine phi. Now this is equal to actually v root 3 by 2 minus of root 3 plus 1. Okay, so if we do v, then it's going to be root 3 by 2 minus half. Okay, sorry, it's minus root 3 minus 1. So this is going to be equal to root 3 minus 1. So v actually becomes 2 meter per second. Okay, so the speed of the ball with respect to surface is 2 meters per second. We'll again recapitulate how we derived the equations. So its velocity makes an angle phi with the x-axis and it hits the trolley. So therefore, if you see, this is v, and let us say it was fired at an angle phi. So therefore, in this component, it's v cos phi. In this direction, it's going to be v sin phi. Okay, so in time t, it's going to cover v cos phi into t, and here it's going to cover v sin phi into t. But because it has hit a, so therefore we can write that v cos phi t is going to be equal to a. Okay, and v sin phi t is equal to a plus root 3 minus 1 into t, because this has already moved up till here, and this is root 3 minus 1 into t. Okay, so so from here we get these two equations we get, and then it is asked that what is tan theta. Okay, so tan theta is so we calculated VA, we calculated VB. So VB with respect to A we calculated, and therefore this is going to be V divided by Vx, which is 1. So therefore theta is going to become 45 degree. And we have to find the speed of the ball with respect to if phi is equal to 4 theta by 3. So therefore phi is 60 degree. Now we just substitute things here. Phi becomes 60 degree and we can calculate V. Thank you. Okay, an object A is kept fixed. Okay, and the object, it is 3 meters and 1.25 meters. Okay, that's mentioned here. At time t equal to 0, the plank starts moving along in x direction with acceleration 1.5 meter per second square. So this is 1.5 meter per second square. At the same instant, a stone is projected with the origin, so u, and let us keep the angle also theta. Stationary person on the ground, what he observes is that the stone is hitting this object A at an angle of 45 degree downwards. So therefore, तो ये कुछ ऐसे जाएगा. This is how the object goes, and it is going to hit, and the angle is made is 45 degree. So now in this direction, it's always u cos theta of the stone, and initially it was u sin theta in this direction. Since it is hit here, so x velocity is not going to change, it's going to be u cos theta only. Y velocity also, because this is 45 degree, so therefore magnitude has to be same, so therefore it's minus u cos theta. So now we can clearly see that after time t, this the velocity in y direction becomes minus u cos theta. So therefore we can write u sin theta minus gt is equal to minus u cos theta. So therefore u sin theta minus 10t is equal to minus u cos theta. So this is first. Okay, good. Now it is going to hit here, so therefore the x and y coordinates of both the stone and the object A on the plank should be same. Okay, so since x and y coordinates have to be the same, so therefore we can write for a stone in x direction how much it goes. It goes u cos theta into t In y direction it goes u sine theta into t minus half gt square. This has to be equal to the x and y coordinates of the object A. So this is, so object A is just moving in the x direction. Already it was 1.25 meter in the y direction, so therefore y direction I have written, and in x direction it is moving with half, 1.5, so therefore half into A into t square, and already it was at 3 meter before, so therefore plus 3. So these are the three equations. Now let us solve it. So we can see here clearly. See, we know u cos theta t, we know u sin theta t. So let us multiply this here with t. So therefore u sin theta t, that is 1.25 plus half gt square, that is 5t square, minus 10t square is equal to minus u cos theta t minus of half into 1.5 t square plus 3. So therefore this is 1.25 minus 5t square, which is equal to minus 0.75 t square minus 3. 3 comes here, it becomes 4.25 is equal to 4.25 t square. So therefore t square is 1, so therefore t becomes 1. Okay, so 1 second. Now we have to find u, the velocity. So the initial velocity in x direction is u cos theta, so therefore we can, from here we can find out, so u cos theta into t, that is 1, should be equal to half into 1.5 plus 3, which is 3.75. u sin theta we can find out from here is going to be 1.25 plus half into 5. So therefore this is 2.5 plus 1.25, which is 3.75, right? Oh, this is no, this is half into g t square, so the g is 10, so this is 5. So this is 5 plus 1.25, so therefore it is 6.25. So therefore in I direction, x direction, it's 3.75, so therefore we can write 3.75 I cap plus 6.25 j cap. Okay, this is the answer. Thank you.